But anyway, the next order of business is I'm very happy to welcome Nardine Osman, invited speaker. Nardine is a tenured scientist at the Artificial Intelligence Research Institute of the Spanish National Research Council near Barcelona. And as we're going to find out today, her research focuses on value engineering, which combines aspects of multi-agent systems, normative systems, agreement technologies, and formal verification, and is about engineering systems that can recognize and understand human values. Nardine is also leading some projects on that, a Spanish project on value engineering, and is a lead scientist in an EU project as well. So I'm very pleased to have you here. Nardine managed to get here despite having a cancelled flight, so we're very lucky. So over to you. So we've got 55 minutes.
Thank you very much, Stephen. Thanks a lot first for this opportunity. I'm very happy to be here with you and talk about the work we've been doing at the Institute in the last few years on the topic of value engineering. The title of the talk is Value-Aware Multi-Agent Systems. I'll be talking, the work that I'll be presenting here, I think is actually the result of collaboration with a number of people from our institute and from other institutes, as you can see. Actually, at the bottom, we also have some medical doctors. These have been working with us on one of the applications that I'll talk about as well today. You'll see their faces popping out throughout the talk, and you'll see where each one has contributed, basically. So I'll divide the talk as follows. I'll start with a little bit of motivation and vision of our work. Then I'll go on to talk about the proposal for us to formally represent values. I'll talk about some of the value alignment mechanisms that we have developed. I'll present a few real-life applications as well before closing. So let's get started. Okay, what is value awareness first? First, there's the topic of the value alignment problem. This has gained a lot of attention in AI research in the last few years, and it can be summarized as follows. How can we ensure AI systems' behavior is aligned with our human values? That's the value alignment problem. And usually here, you can either think of a single agent or a multi-agent system. If we're addressing the issue of a single agent, that's what we're usually assessing is the decision-making process of that agent to ensure that its behavior is aligned with certain values. If we're talking about a multi-agent system, then usually the focus is on the norms, because norms are the common way for us to mediate behavior. We use norms to mediate behavior, basically. So you try to check whether the norms of a multi-agent system are aligned with certain values. Now, we propose the following definition for value awareness. We say value-aware AI is an AI system that captures and understands a human's value system. It needs to abide by that value system, and it's capable of explaining its own behavior and that of others in terms of that value system. In order to capture and understand our human values, we need mechanisms for value learning. We need the AI to be able to know what are our values and model them. We also need value representation to make them formal and computational so that we can reason about them. In order to abide by a value system, we need value alignment mechanisms. And then to explain, we need value-based explainability. I won't cover everything in today's talk. I'll cover some of these things. But when we're talking about, when we're doing this, we go a little bit beyond value alignment, and we talk about value awareness. So we're not only raising awareness on the agent and the multi-agent system level. You'll see in some of our applications as well that we are raising awareness on the human level. So we cannot control how humans behave, but we can provide them with feedback on their own actions and how those actions are aligned with certain values so that they can make better decisions. So basically what we're saying here is we want to introduce values as a new construct in AI. And how would this fit in the big picture of other constructs that we have? So here I have this image. Usually there's a number of different motivations that drive our behavior. These motivations can be on the individual level or on the collective level. On the individual level, it could be my trait, my personality. It could be my beliefs, it could be my goals, it could be my values. All of these influence my behavior, drive me to behave in a certain way. And this is a very complicated topic to go from, because there are several different motivators of behavior. On the collective level, you can have norms that would try to motivate behavior in a certain direction. You can also have values, social values on a collective level. So basically, these are the motivators that influence our behavior. Our behavior would result in changing the world in a certain way. You have certain outcomes for this behavior. Now, in the past, we've worked with some of these issues here. For example, we've taken norms, and we try to ensure that behavior is aligned with certain norms. We've also worked with goals in AI. So basically, you try to make sure that the outcome fulfills certain goals. And when it does, then you say that this behavior is aligned with those goals. And we are saying it's time for us today to not forget about those, but to add to those the issue of values. Let us also consider values and see how much our behavior is aligned with certain values. So here we want to be able to evaluate the outcome of our behavior, whether it's supporting certain values or not. And if it does, then we can say that this behavior is aligned with those values. And if we say the behavior is aligned with those values, then we can then say that whatever motivator that resulted in that behavior is also aligned with those values. So if the behavior is the result of norms, then we can talk about the norms being aligned with the values. If this behavior was the result of my beliefs, then I can say these beliefs are aligned with those values. So that's the big picture, that's the motivation that we have. Now I'll start with the second part of the talk, value representation. So until now, there have been a lot of work popping up in the last few years on the topic of values. To my knowledge, we haven't come across a formal model for value representation. In many cases, values are used as labels. So you put the label equality, the label fairness. So this is the attempt that our proposal for representing values. But before we do that, I'm an engineer. It's very difficult for me to define values. So I went to social psychology to understand what values are before we present our proposal. So in social psychology, you can find a very long list of value definitions. The issue is not easy here. This is only a selection of those definitions. But going through the literature, you notice there are certain topics, certain aspects that reappear, and I highlight them here using different colors. So for example, on the nature of values, some say they are beliefs, that's the part in orange, some say they are a conception, principles, convictions, and so on. What are values for? That's the part highlighted in green. To influence behavior, to guide behavior, to select, to realize a good society, selection or evaluation of behavior, people, and events. And you do that based on the part in pink. You see what's important, what's desirable with respect to modes of conduct, actions, and state of existence. This is the part in yellow. And values can be held by the part in blue, individuals or groups. So we made a summary, basically, of the important aspects of values from the social psychology, and this can be summarized here. So we say values are beliefs, conceptions, principles that guide behavior by considering what actions or outcomes are desirable or essential for either individuals or collectives. We are not interested in this work in value categories. So Schwartz, for example, is the most famous one here. He proposed a theory of basic human values. You can see on the right, basically, the values and the categorization of the different values that beliefs are universal for us humans. There are many others that provided different value categories focusing on specific contexts like values for employers, values for employees, and so on. We are not interested in specific categories. We follow the path of the work in value-sensitive design. We say values should be elicited bottom-up from stakeholders. We do not come in advance and say these are the values. we need to allow the users of the technology, the people, to decide what's important for them, especially because we believe in values changing over time and with context. So privacy became more important after the internet. Sustainability has gained more importance lately. So things change over time. So that's our stance. So let's get now to the formal approach for value representation. This is actually something that I'll be presenting tomorrow at the conference. And this is work that I did in collaboration with Mark Dinverno from Goldsmith College London. So our proposal is really very simple. We say, let's use a taxonomy for the representation of values. This is similar to semantics networks, if you want. In this taxonomy, this allows us to say that values are abstract constructs. You have abstract concepts like fairness. So if I ask you here, what do you think, how would you define fairness? I'm sure many of you would give different definitions because many of you would think of different applications in mind. So you can think of fairness as reciprocity, you can think of fairness as fair treatment, and so on. You can have many different concepts. And the taxonomy allows us to relate these abstract concepts. But our proposal also introduces, you see the abstract concepts are the circle-based nodes, but you also have the square nodes at the end as leaf nodes. And this is where we formally define those different concepts. Here you have a property allowing us to check how much this value is being satisfied. So if we take a look, for example, at balanced division of labor in a specific setting, you can say, here you want to make sure that the distribution of allocating the tasks over volunteers is as close as possible to the uniform distribution. So here we're becoming very concrete. This gives semantics to values, and this is what makes values computational. Now, not all values are equal. Some are more important than others. So we say it's important to have the level of importance of different nodes. It's difficult in reality to attach a number to every single node. We address this by proposing a propagation mechanism where, given a few importance measure, you can propagate those numbers to the rest of the tree in a way that makes sure all the importance is coherent within the tree. Then it's the importance what drives or influences behavior. So the alignment here is evaluated as an aggregation of the degree of satisfaction of the important property nodes. So we take the importance of the property nodes into consideration. That's the very general basic idea, if you want. Now, we also say that values change with context and over time. So the taxonomy is really dynamic. So you can imagine you're in a situation, you design your application, you start with a specific definition of values, then watching how things unfold, how people behave, you decide to adapt that, you find another definition for that value concept, in this case, the balanced give and take. You continue using the application. Over time, you decide you want to incorporate another new conference. And as such, you can imagine how, with experience, the values taxonomy would evolve and grow. So everything here is dynamic. You might also have different views of the value fairness in different communities. So you can have one community focusing on one part of the taxonomy and another community focusing on other parts of the taxonomy. Sorry? This is the importance of each value node. So each value node...
Repeat the question for the audience.
Yeah.
I mean, people on Zoom.
Yeah. So this is basically the importance of the different value concepts. The numbers here, the parts underlined, this is an example to say like these numbers can be provided by the user or learned, and the others can be deduced because we don't expect to have all the numbers pre-specified. But it's basically the numbers tell us the importance of that value concept. Because here it's just simple, just one branch, the numbers have to be aligned. You need coherence. So they're the same from top to bottom. Anyway, and values, we said, are held by humans, individuals or collectives. So what the AI is doing is it's trying to model our human values here. And that's it, basically, for our proposal. you can see more or less this is aligned with the ideas, the definitions from social psychology. The only thing that doesn't appear in the definitions is the concept of values changing over time and with concept, but it does exist in the literature, but it doesn't appear in the definitions. So yeah. So I'll move to the next section in the talk, and I'll talk here about the different alignment mechanisms that we have designed. This is the very first work that we did that was around 5 years ago. In that work, this came before the formal representation of values that I just presented. So in that work, the values were understood as preferences over states of the world. So we say, if, for example, gender equality is important for me, then I will prefer a state of the world where the male and female salaries are closer to each other if they have the same post than other states of the world. So this is an example. Norms for us define the possible worlds, what could unfold, basically. And the value alignment, again, I'm presenting the ideas very briefly here. So the value alignment basically becomes how much are the value alignment of the norms with respect to that value, become how much are these norms taking us to preferred states of the world. And we calculate this as an aggregation and an accumulation of the preferences along the different transitions and considering all possible paths. So this was a very initial proposal on how to make value alignments computational. We played with a toy example, the prisoner's dilemma, where you have alpha and beta either cooperating or defecting, and with you get different rewards based on the actions that you take. We thought of different possible norms that we can apply here and different possible values. The norms, for example, you can take the default prisoner's dilemma as it is without any taxing. The second one is you introduce incremental taxing, where you have to give back a percentage of what you gain. And the third is the fixed taxing. You always give back 1/3 of what you gain. The values, we thought of two opposing values, equality and personal gain. So you can either be pro-equality or you can be pro-personal gain, increasing your personal gain. These are the top and the end. But then you can have values that are a little bit in between. So for example, you can say, I'm with promoting equality as long as my personal gain isn't lowered, or I would prefer to promote personal gain as long as the equality is not lowered. So here you have ideas of different values, different norms. This is the formal specification of the values and the norms. And then we run a simulation with the agents, alpha and beta, performing in different ways. And you can see from the results here, using our equation for value alignment, you can see that the norm 1, where you support equality, the value of the value equality is best supported by the norm 1, which is basically the incremental taxation system. If you prefer the values in between, then any of the norms would do. They are more or less the same to promote those values. So here, this is an example of how you can make things formal and assess the alignment of norms with values. Then the next piece of work that I will present, we had a student, Nieves, that joined us during her master's and built on top of the work that I just presented. And in her work, basically, she was focusing on finding the norm parameters that would optimize the value alignment. So you want to have the best value alignment. The value, again, we're focusing, at least in this talk here, is equality again. You define it as the Gini index here. This is the equation that's used by the UN to assess income equality or inequality in the world. The game that we have here is a simple tax game. You have a number of players that have to pay taxes. There's a certain percentage of the taxes that they pay based on their income. The taxes are collected into a common fund, increased a little bit, and then redistributed over the agents again. Some agents don't pay taxes. If they are detected, then they have to pay a fine. The norms here, basically, what we're trying to find, here you have the parameters of the norm in the middle. what we're trying to find are the parameters that would maximize value alignment. As I said, this becomes an optimization problem, and solving that, we find, for example, that the best we can do is align with equality to the degree of 0.95. And we do that when we set the following numbers. So the percentage of how much taxes you need to pay based on your income level. These are the 5 different numbers on the top. The redistribution, how much you give back, the percentage of catching evaders, and the percentage of the fine, how much you have to pay. So here, we're finding the best parameters, basically. Nieves then developed a couple of other tools that would help us further analyze norms with respect to values. So we can use the Shapley value from game theory, and that would essentially allow us to know which norm is contributing most to promoting a certain value. So we found the parameters, the set of norms that would maximize equality. Now, which of those norms is contributing most to equality? We see here, given the Shapley values, that actually the first norm, the collection of taxes, is enough to actually shrink wealth distribution. You can also compare values. You can try to find the set of norms that maximize one value and then see how much is it aligned with another value. And when we do this, we realize, for example, optimizing for equality in a way ends up by neglecting fairness. However, optimizing for fairness ends up respecting equality to a certain degree. So it's not really symmetrical. So these are some of the tools for further analyzing norms with respect to values. The last piece of work, so Nieves ended up doing her PhD after her master's. She jumped into other topics. And then at the end of her PhD, she came back to the issue of value alignment. And here, it's about value alignment from the point of view of others, perspective of others. So we talked already about the alignment of norms N with respect to a value V. That's the part that's already achieved in the previous slides. Now we want to talk about the alignment for agent alpha, but from the point of view of beta. So what does alpha think? Beta thinks that the alignment is. And here, this is just one jump. You can also make it general. The perspective can be, what does alpha think, beta thinks, etc., gamma thinks about delta concerning the alignment of norms with values. And before I present the proposal, just a very quick overview, because this reuses some of the work she did with her PhD. So the part in the at the bottom, we already talked about it, how to assess values with respect to the outcome of certain behavior. She also developed a game engine that would take in a set of norms and would present the extensive form game that would allow us to know the possible outcomes of the norms, basically. This is the second part of her work. Another part of her work was using theory of mind to try to have like the theory of mind of another agent, to try to assess and use abduction to learn new information. She applied that to beliefs in a game setting, Hanabi game, and now we want to apply it to values instead of beliefs. So the proposal for the perspective-based alignment is as such. The alignment becomes an aggregation of, let's focus on the last part first. Basically, this is how the value is defined. The value V defined from the perspective P. We assume the perspective is known. The definition of that value from that perspective is known, and that's the equation for evaluating that value. We evaluated with respect to the possible outcomes Z. Z are the list of nodes in the extensive form game that are obtained from the game engine that was built. So basically, you get this, you feed it in the set of norms, you get the possible outcomes, and you take each of those possible outcomes and evaluate the alignment of that outcome with that value V. And you also take into consideration the probability of that outcome. The probability of that outcome can basically be obtained using game theoretic solution concepts like Nash equilibrium. And that's the general concept basically here. So here we have another example. So in this example, this comes from Ostrom's examples. You have a group of fishermen that are trying to fish in the same location, more or less. There's a community of fishermen that go to one place and you end up with violent behavior. Then the community can start introducing norms, like the first to arrive has the right to fish there, or you can try another set of norms. The first to announce have the right to fish there. We'll get back to those norms in a bit. But that's our scenario. That's the example we're testing here. Let's assume we have two agents here, Alice and Bob. Now, Alice might have her own definition of what equality is. In her definition, this is the Gini index. Equality is defined through the Gini index. And Alice as well has an idea of what she believes Bob's definition for equality is. It could be the same as Alice's, it could be another definition. In this specific case, she believes that Bob defines equality as the ratio of minimum to the maximum. Now, how does Alice obtain this knowledge about Bob? This is not presented here. This is actually ongoing work that we are doing, trying to learn the values of others, learn their equation of values by watching their behavior. But I'm not going to talk about this here today. So that's it. Given this, we take the three different possible norms, the default rule, not having any norms, the other one, the norm that says first in time, first in right, and the third, the first to announce, first in right. We have these game trees, and then we assess alignment. For equality, we assess the alignment for Alice, and Alice also assesses the alignment for Bob. And we do this for equality and a number of other values as well. And you try to find the best solutions in a way for Alice and Bob here. So the interesting thing in this work is that this is useful when we have agents collectively trying to agree on the norms of their community. In this sense, trying to understand others' point of view would help you try to find the most optimal set of norms. So if you're in a negotiation, for example, with others over the norms, this would be the tool that you'd need here. So I'm going to stop here with respect to the mechanisms that we've developed, the theoretical approaches that we've done so far. And I'll focus now on real-life applications. So in the last few years, last couple of years, we were lucky to have a number of projects that allowed us to investigate a number of real-life applications. I'll present 3 of those here. The first is actually work being led by Alba, one of our students. She's with us here, and she'll be presenting this on Thursday as well. So I won't talk about the details, but I'll give you the general idea of what we're doing here. And the objective here is to try to assess the impact of certain norms on poverty. So the question is, can we evaluate the impact of norms on poverty? Poverty is a very big topic. We choose to focus specifically for now on minimizing income inequality. Alba is considering to assess other issues like homelessness and so on. But for now, in this work, we focused on minimizing income inequality. Again, the Gini index is the equation we define our value with. And this was tested for Barcelona's metropolitan area. The idea here is to use agent-based simulations. So, one second. So we have different agent profiles. Those agents we would simulate the actions of those agents by using the needs-based model. This was developed by Frank Dignam and Virginia Dignam. They used it during the COVID, for the COVID example. You simulate agent actions, and then when you have those actions with the norms in place, you assess the outcomes, what would happen. In practice, I'll jump here. In practice, we worked with Barcelona City Hall to select some of the relevant norms on the topic. We selected 6 norms with them. We took data from the Open Data BCN to help develop the agent profile. We got the demographic information from there about the agent profile. And then Alba had to invent some other things about the profile. This is something that's being addressed in the second piece of work, but that's for another time. and as well invent the rules, the need-based rules. So for example, if you're hungry, then the probability to go shopping is higher. If you're bored, then the probability to go to the cinema is higher. So these are the need-based rules that would drive the action of agents, basically. So given the agent profiles with the need-based model, we can simulate actions such as going shopping, buying groceries, sleeping on the street, etc. With the norms that we have and those actions, we can assess the outcome. So for example, if you decide to sleep on the street, then there's a high probability that you'll get fined and so on. So in the outcome, what we're focusing on is the income inequality. And by assessing that, so we can play with the norms, assess the impact of different norms, and then we can see which norms impact inequality more than others. So that's the basic idea of the work. I will stop here. Then I'll jump to another topic, another application domain. Here, the application domain is the medical domain. This is work that we're doing with Hospital del Mar in Barcelona. Some of our colleagues here are medical doctors. Yeah, so here the objective is to try to assess the alignment of medical decisions with values, but not only medical decisions, we also want to try to see whether we can assess the alignment of medical protocols with certain values. So these are the two main questions. Can we evaluate the alignment of medical decisions and the alignment of medical protocols? Medical decisions is on the agent level, the protocols is at the hospital level. We started discussing, working closely with them, having discussions on which protocol to use. They have thousands of protocols at the hospital. We decided on a protocol called the NEAT protocol. That represents the therapeutic intensity level. So basically the accepted intensity level of a treatment to be given for a given patient. This is the protocol that had most cases of ethical dilemmas popping up. This is why we chose to focus on that. Basically, when a patient arrives at a hospital, they discuss their case with their doctor. The doctor explains the situation, what could be done, takes into consideration what the patient wants to agree on a specific intensity, a therapeutic intensity level. And those levels vary from number 1 to 5. 1 representing, please do anything possible to extend my life. 5 representing, just focus on comfort measures. And then you have things, different levels in between. The problem with this domain is that there was no data available for us to work with. So we've been spending a lot of time with the doctors to try to compile a corpus. This is what we have here. So we selected 75 patients that were anonymized, of course. And then the data set included the following information for each patient. First, there's the NEAT level, which was assigned to the patient when they entered. Then there's the patient criteria. The patient criteria describes things like the age of the patient, the complex chronic disease, the expected survival of the patient when they first walked into the hospital, their clinical risk group, their functional independence. I'm just giving examples: cognitive deterioration, emotional state, current comfort level, and so on. We chose criteria that are, we designed these criteria with the doctors to have criteria that are general enough to be applied to all patients in the hospital instead of going into specific diagnoses, and still informative enough for doctors that they thought are good enough to try to make decisions based on them. So with these criteria, we then have a set of actions. This comes from the protocol, actually. So the protocol says for each NEAT level which actions are permitted or not permitted. And the list of actions is predefined, it's concise. We have 11 actions. Here are some examples, like perform a transplant, move the patient to ICU, perform dialysis, palliative surgery, etc. And then the last part, number 4, is the how the patient criteria after performing the action. So how did the action impact the patient criteria? Now, that's the corpus for us. But after building that corpus, we started working with the doctors as well, intensive sessions to try to define the values. So we selected a few cases. We asked the doctors, so did this action promote or demote that value? And they would have discussions amongst themselves. They would agree on an answer. And then we'd ask them why. Why do you think this value was promoted? Or why do you think this value was demoted? And basically what we were trying to do here is trying to formally define those values. I forgot to mention that the values here, by talking with the doctors, they said these are the 4 basic values that they are trained on. The 4 bioethical principles from the literature: beneficency, non-maleficency, autonomy, and justice. Justice is very difficult to define, so we haven't been tackling this until now. Autonomy, it's more about the patient understanding the state and what they want and so on. So we are providing a definition for this. But beneficency and non-maleficency were the easiest because these had to do with the criteria that we were defining earlier. So it depends basically how the state of the agent evolves. That's how you can assess the value. So given the doctor's feedback, we tried to construct equations that, in a way, general way, it tries to aggregate considering the important criteria for each of those values and how those criteria evolve from C to C prime, the C being the initial state, the C prime being the next state. That's the general idea. Then the system essentially takes as an input the patient's need level and their state, the current state, the criteria. The doctor would enter the actions that they are considering. The first part is to try to calculate the expected changes in the patient's state. We use that using the corpus to learn from the data we have in the corpus. And the next part is, based on how the state is expected to evolve, we use the definitions that we are defining for values to try to evaluate for each action how much does this action promote or demote each of those criteria. And that's the idea. We have things implemented. The difficulty is in the first part, the learning from little data. This is what we're tackling at the moment. Then the idea is, when we have the alignment of actions, we want to move to the alignment of protocols. And this is, we haven't started tackling this, but this should be an easy task, more or less, because if you have the alignment of a certain action with a value, you can interpret from that the alignment of norms with respect to that values. The norms, we take norms to be defined as what is permitted, if the action is permitted, forbidden, obligatory, and so on. And if you can deduce the alignment of the norms, then you can also deduce the alignment of protocols, because protocols essentially are simply a set of norms. So that's the direction we're heading, basically, in this domain. The last use case, this is also ongoing. We don't have any publications yet. This is about working with firefighters. This is another project. The objective of that project initially was to focus on using simulations to train firefighters. And then in our discussions with them, they got really interested in the work we're doing on values. They said that different fire departments, especially if you consider different geographical locations, like different countries, they have different values. They prioritize values very differently, apparently. So it would be good as well when training the firefighters to try to train them for specific values. So the person might have a tendency to give preferences based on their own value system, and the training could help direct them to start adopting the value system of their own fire department. So that was the motivation and the general idea that we're doing here. It's similar to the medical protocol. So if we take a look at this scenario here, we have a scenario where there's a building on fire and the firefighters need to react to that situation. In the medical protocol, we focused on the criteria of the patient. Here, we're focusing on the state of the building. So you have a number of floor levels, you have the fire intensity on each level, you have the occupancy of each level, the equipment readiness, the visibility on each level, and so on. So this is similar to the criteria in the medical protocol. This tells us the current state of the building. Then you also have, like before, a predefined set of actions that you can perform, whether you evacuate, whether you contain the fire, whether you perform aggressive fire suppression, whether you take your time to coordinate with other agencies, police and others, or whether you also take your time to assess and plan And depending on the situation, depending on the current state and the values you want to promote, some actions might be recommended more than others. The value definitions, we worked with the firefighters to tell us their important values. And we're actually working here with ChatGPT to help us define those values. So professionalism, for example, this is what ChatGPT told us. So if you evacuate occupants, then you get a moderate reward. If you contain the fire, then you get a high reward for that specific value. If you perform aggressive fire suspension, then you get a low reward. If it compromises firefighter safety, higher otherwise. So here we're using ChatGPT to help us define the values. And then we want to take all of this. We're also using ChatGPT to help us define the transitions. So here we're defining the problem as a Markov decision problem. So with this, we'll take this back to the firefighters and try to confirm that what we're defining here is correct, or we tweak it based on their input to finalize this. And then it becomes easy to evaluate the best actions to maximize basically alignment, because the values would be the rewards in that MDP basically. So that's the last piece of work. This is bringing me to the end of my talk. So we defined value awareness today. We talked about the different mechanisms that are needed to achieve that. We presented our proposal for value representation. We presented some mechanisms for value alignment. We didn't talk about explainability, but the approaches we've been following are symbolic approaches, so explainability should be easy here. We didn't talk about value learning. This is ongoing work that we are doing. If you want to hear more about that, we can chat later. And we did present some promising real-life applications. And for me personally, what I really liked about this is that the feedback from firefighters, from doctors, was very positive. They were very interested in the work, although the topic is very new. So they get trained, both of them, the firefighters and the doctors, they get trained, they receive training on the values. But in their everyday life, the doctors told us, like, when they're making a decision, they do not think of the values. And just by having the discussions with us, they're starting to change. So now they be with the patient and they start setting the values in their mind. So that's interesting. And that's it, basically. I just want to take a minute and make a couple of announcements here. I want to say that with Luke Steels, we are organizing a workshop track at ECOI on value engineering. ECOI is happening in October in Santiago de Compostela, Spain. The deadline for this is May 31st. So if any of you is working on any related topic, preliminary work is most welcome here. There's also a special issue at the Journal of Autonomous Agents and Multi-Agent Systems. The special issue is on agreement technologies. That was created as a tribute to Carlos Sierra's research. So as well, if you have any work on this topic, I would like to invite you to submit to this special issue. The deadline for that is June 15. And that's it. Thank you very much. Questions?
Okay, thank you, Nardine, for that very interesting talk. Lots to think about. So I imagine we have plenty of questions.
Thanks so much, Nardine. I think this is really good to see this real world applicability as well of the work. I think I have a very quick question. Like, how do you define fairness? That was one thing. Like, you defined equality as Gini index. How are you defining fairness? The other part was in the hospital scenario, you're discussing that values of doctor and how doctors have 4 values. What about the values of patients? How do we consider that? And each patient will have different value preferences. And typically they'll only prefer them getting better, right? So not about, they won't really worry about semi-autonomy or anything else, right? So what are your thoughts on that?
Yeah. Concerning the first question, how do we define fairness? So even equality, so this is something I said at the beginning, that we don't take a predefined set of values. Even the definition of values, we expect to get these from people. Now, you can do this in 2 different ways. You can either ask the stakeholders to tell you what values are important for them. Like with the doctors, we're actually sitting with the doctors to try to define those equations. You cannot always do that. It's not easy. It's time consuming. Another work that I didn't present is to try to learn the equation that defines those values from watching the behavior of the agent. So this is an alternative. But the point I'm trying to make here is that the definition of a value comes from people, from the humans, and not from us, if not from the AI, not from the system. The equality genie is one example of defining it. You can find other equations. You can find other people that define it with different equations, and that's fine and that's accepted. Fairness, if we take a look, I went through this quickly. Tomorrow, hopefully, I'll present it with more detail. But if you take a look, fairness here, for example, we did consider fairness for a specific, we did consider fairness for a specific application in mind. The UHelp application is an application for finding volunteers within your social network. The thing is, with values, you always have to define it for a specific context. It's very difficult to provide a general definition of fairness. So here, what you see here, the different definitions of fairness came from actually people we were chatting with when designing the application. So in a community of single mothers supporting each other, volunteering to help each other out with daily activities, they said they didn't want people that only ask for help. You need to have a balanced give and take in a way. And then we considered using that UHelp application for another community that supports the elderly. In that case, it's impossible to ask for balanced give and take. It's usually the elderly that ask for help and volunteers in the community that offer help. In that case, fairness was defined in a completely different way, and you have another definition, completely different definition. So this is what I said, it needs to come from the stakeholders, and it's something that evolves over time. So the community of single parents can say, you know what, that definition also is interesting for us. So you can combine ideas and you can combine equations. So that's the answer for the first question. And the second question, it was about the values. Yes, absolutely. At the beginning of the project, we said you have to consider all stakeholders. The stakeholders are the doctors, the hospital, the patients, but the use case is very complicated and difficult. I mean, just working with the doctors alone to understand the basic values from the literature is time consuming enough. So ideally, you would also want to try to get the patient's values, but for now we are leaving this on the side. But ideally, you would take that into consideration and you would plan for both the hospital values and the patient values. But still, I want to say here that the patient values, in a way, they're not also the same for all patients. In a way, they're reflected at the moment in the need level. So a patient might say that currently they prefer to get better. The need level, in a way, reflects some of those values, that you have to do everything to try to extend the life of the patient, or the patient can decide that, no, comfort is the most important thing for me. So these are, in a way, they are reflected there.
So your hand first.
Thanks so much for the really interesting talk. So I guess I have two questions about value representation, and this is coming from. So I guess I've been part of the AI safety community, research community for quite a while, and you know, in that community, it's been common. I think initially when people started talking about value alignment, they often framed it in terms of like, well, I actually don't really care. Like values is a really big word, but let's actually try and formalize things in terms of people's preferences, right? And so the move was like, you know, whatever it is people conceive of their goals, values, norms, whatever, ultimately you can always like turn that into some kind of preference ordering over outcomes. And we just need to learn that preference ordering over, you know, what people prefer, like, you know, over like all possible life outcomes. And then we can just maximize that, and that we're going to call that value aligned. And so I think Stuart Russell has this kind of pretty strong view of like what it means to be, for a system to be value aligned. And that's quite different from the view you're offering here. Maybe, I don't know. I'm just curious whether you think of it as different, and like what you would say to someone like Stuart Russell, who maybe thinks that we can just talk about preferences and we don't have to talk about these abstract constructs, right? So that's one question. The second question I have that's sort of related to that is, I guess the question of like formal representations and the value of formal representations. So I think more recently with the sort of growth of large language models, I think people in that community have been starting to try, okay, actually, we don't need to do this reinforcement or inverse reinforcement learning thing. It turns out the language models kind of already know what all these words mean. And so there's this paper, Constitutional AI by Anthropic, where they basically tell the language model to be like, to critique itself based on like informally specified values. That's one way you can think of it, where you just sort of tell the language model, please select the response which is less toxic, less racist, less sexist, or please select the response which is more thoughtful, more empathetic, more like what a friend or a therapist would say, right? And that's sort of, and it's actually able to do that to some degree in a way that sort of gives itself feedback to improve itself. And that seems to work, at least to some degree. And so I'm curious, like, that's one way of doing things. I'm curious, like, what's the value of like doing the sort of more formal thing? Yeah.
Okay. Concerning the first question, I think we're in a way aligned with what you're talking about, because if you take a look at the properties at the leaf nodes, that's in a way telling what's important with respect to specific goals that you're trying to achieve. So that is still here. And in the application domains, this is what's being followed. So the focus until now is using those square nodes, the leaf nodes at the bottom. Why do we have the rest of the tree? That's still theoretical at the moment, but it comes from a view that, okay, we're predefining what's important for a specific context. So for a specific context, you only care about the squares, the preferences over the goals or preferred states if you want. But if you want to start to get into negotiations or to reflect upon those values, then we believe that this is where the abstract part would help the humans. So we haven't started working on that yet, but we think this is where the rest of the tree with the abstract nodes would come in. Concerning the second question, I agree that the LLMs can do a lot, but you cannot fully trust it. So as I said, for example, with the firefighters use case, we started using the LLM to help us define some of those values. But even then, you have to actually direct it. You have to tell it how you view that value, your definition. When we first asked it to give some ideas, its definition was far away from the firefighters, what they told us. So you need to direct it. Number one, you need to direct it. Number two, you need to confirm. So we're going back to the firefighters to confirm that these definitions are going to work. They agree with them. So they can be used, but in collaboration with the humans. So that would be my response to that. And we are trying to use them in the firefighters use case.
Thanks. Very interesting talks. Actually, we are thinking a similar project in New Zealand as well. And when we talk about the delivery of value in New Zealand, one big thing at the moment is about the productivity in terms of medical decisions and so on. And I don't know how many people experience the New Zealand public health system here. If you got caught in the kitchen, you go to ED, good luck. So like the waiting time is a big thing here. And that brings an interesting concept is that the way how you realize your value over the waiting period might change. So I'm just wondering, for your model, for your concept, do you have for example, time dimension being considered, or just make the assumption that all the medical decisions will be made immediately and the patient can get the treatment immediately? Thanks.
Time dimension in terms of how you view the value, how you define it, right?
Yeah, basically how long the patient needs to wait to get the treatment.
Yeah. So I would say that, yes, we did say that this is dynamic and this would change. So you can have new definitions, change the parameters of some of your equations. This is doable. We expect this to happen by learning from past experience, and you would update your definitions accordingly. Yeah, but the tricky part is try to learn those from experience. That's the tricky part that we didn't talk about today. But
Okay,
yes.
thank you.
Okay, we've just got a couple of minutes left, so.
Hi, so thank you for the talk. Building somewhat off of what you were just talking about, basically combining those individual values into sort of one bigger value. I'm curious about the parameters you were talking about and whether you've noticed some any instability or any like trickiness with that parameter tuning for those individual parameters, because you're essentially doing kind of a multi-objective scalarization to get these values, I guess. I'm wondering how sensitive the values are to those parameters.
I'm not sure the parameters of in the value definitions, you mean?
Yes, if you go to the slide with the equation, I think it's like 2 or 3 slides later.
Here or later?
A little bit later, I believe. You had one slide with, oh, I don't know where it went. You had one slide with basically, it's a summary and you have it, I believe you had a summation and it was multiplied by like a parameter, I believe. Okay. I don't remember which slide it's on. Maybe it's this one. So I'm just curious, like how sensitive this is to any kind of parameters that you're incorporating, because you said that you have to basically incorporate some parameters.
Okay. So the parameters, the value definition, when you're doing the value alignment, you're doing it for a fixed value definition. We expect the alignment to the definition of the value to change over time, and then you redo the calculation for the new equation of the value. Here in this specific equation, the F is defines the how to evaluate the outcomes for that specific value. That's a fixed equation that you would get. The P is the probability of each of the outcomes. The probability is here, as I said before, the outcomes are obtained from the norms. So you have the norms that would tell you what are the end states that you could possibly reach with these set of norms. That's all the set of possible outcomes. And then the probability of those outcomes, that's the P. These come from the game theoretic solution concept. So you would choose, if you believe a Nash equilibrium would direct you to what's more probable, then that's calculated accordingly. But yes, of course, it's sensitive to what you choose here.
Got it. Thank you.